in this set of examples, we're going to graph each function and its parent function, and then we're going to describe the transformation. So for this first one, I see that I have g of x is equal to x minus 4. So first I need to determine what is its parent function. Well, I see that I just have an x here, and so that means the parent function, which again is the most basic of the functions, is just going to be f of x is equal to x. So I want to graph both the parent function and the function given here. So the parent function, x, I'm just starting at the origin, and I have a slope of 1, so I go up 1 over 1. And then I'm going to graph my g function. So here I see my slope is still 1, so I have m equals 1. My y-intercept is negative 4, so my b is equal to negative 4. So if you remember back to Algebra 1 to graph a line, I'm going to start at my y-intercept, which here is negative 4, so I'm going to go down 4 on my y-axis. And then my slope is 1, or in other words, 1 over 1. So that means I'm going to go up 1 to the right 1. And then I can also go the other direction by going down 1 to the left 1. And so I get these two lines. So I graphed them. Now I need to describe the transformation. Well, I see that my blue line here for my parent function, I see that I clearly translated down. I still have the same size, shape, and orientation. I just shifted downwards. And I see that I shifted down 1, 2, 3, 4. So for this, I can say that g is, and our word here was translated, four units down from the parent function, the parent linear function. Okay, let's look at this next one. So here I have g of x is equal to negative absolute value of x. And so I need to first determine what function family it's in. I see there's an absolute value, so I see this is going to be an absolute value function, and my parent function for that is just f of x is equal to the absolute value of x. So now I'm going to graph both the parent function and my function g. This time I'm going to go ahead and use a table. So of x, I'm going to put my parent function next, and then my function g. And go ahead and graph 5 points. So when I plug in negative 2 into the absolute value of x, I get the absolute value of negative 2. Well, the absolute value of a negative number just makes it positive, and so this is going to be positive 2. Positive 1. Absolute value of 1 is still just 1. Absolute value of 2 is just 2. And so I'm going to go ahead and graph that first. And so I have negative 2, 2, negative 1, 1, 0, 0, 1, 1, 2, 2. And so I get that V shape. Okay, now I'm going to go ahead and graph my function g. So my function g, I'm just taking the negative of my parent function. And so all of these are just going to become negative. And so when I plot that, I have 2, negative 2, 1, negative 1, 0, 0, 1, negative 1, 2, negative 2. So here I see if I'm comparing from up here, this is clearly reflected. And so I can say the graph G is a reflection across the x-axis from the parent quadratic function. So this next problem we have g of x is equal to 2x squared. So first, I need to figure out the parent function for this. I see I have that x squared here, so that means my parent function is a quadratic function, so that's going to be f of x is equal to x squared. So now I want to graph both of these functions on this graph. So I'm going to create a chart. So I have x, I have my parent function x squared, and then my g of x, which is 2 times my parent function x squared. So I'm going to plug all these in. So here I have -2, and I'm going to square that. And so -2 squared, I get +4. -1 squared, I get +1. 0 squared, I get 0. 1 squared is 1, and then 2 squared is 4. So graphing my parent function, I have -2, 4, -1, 1, 0, 0, 1, 1, and then 2, 4. Now I'm going to go ahead and graph my function g. So my function g, I'm just doing 2 times my parent function here. So I have 2 times 4, which is 8. 2 times 1, which is 2. 2 times 0, which is 0. 2 times 1, which is 2. And then 2 times 4, which again is 8. So applying those points, I have -2, 8. -1, 2. 0, 0, 1, 2, and then 2, 8. So here I notice that my graph g is more narrow than my parent function. And so remember from that, when it's more narrow, that means we stretched our function from the parent function. So I can say that the function g is stretched by a factor of 2, because that's what I multiplied by. From the parent quadratic function. Okay, go ahead and pause the video. I want you to try to do this last one on your own. When you think you have it, go ahead and press play. So this is the answer that you should have gotten for problem number 4. You should have had a graph that looks something like this. And so we notice from this graph that my function g, which is here in blue, is wider than my parent function. And so we talked about up here, when it's wider, then we know that it is shrinked. And we also know this because the number multiplied out in front is between 0 and 1, because the number multiplied is 1/2. It's between 0 and 1, so we also know from that that this is a shrink. And so I can say that the function g is shrinked by a factor of 1/2 from the parent absolute value function.